Ready to make one of these cool rubber band guns? Well, let's go. Hey everyone, and welcome to the latest episode of James Dean Designs. If you're new to the channel, love laser or CNC, make sure you hit that subscribe button down in the corner to get all the latest tips, tricks, tutorials and reviews. Now in today's episode I wanted to go back to basics. Recently I've been using files off the internet to create projects, but today I wanted to do something from scratch, and that's when I came up with the idea of creating this rubber band elastic gun. You can have some cool fun with this, shoot little targets on your desk, that type of thing. And what I'm going to be showing you is the process I went through from drawing it out to prototyping it and ultimately creating the final piece. What I'm not going to go into detail of is drawing every element out. This is just basic shapes that we use in basic drawing features that you can do in your favorite software such as Lightburn, Inkscape, Adobe Illustrator. Now obviously you can attempt to do your own, or you can use the files from today's episode, which are all available in the description area below for free, so definitely do check them out. But for now, let's get stuck in and see how I created this from start to finish. So I quickly just want to talk to you about tolerances when doing this type of work, because the material you're working with will vary in thickness and you need to try and account for that. Now this piece of material on the bottom here is classed as 3mm ply. It's what I actually did a cutting test with, but we can see from the gauge it is actually 2.7 or 2.8 depending on whereabout you measure on the material. Now this piece, which is the material I'm using for today's job, is also classed as 3mm ply, but when we test this we can actually see it's over 3.1. So there's 3 or 4 tenths of a difference there between the two different types of ply that we are using, although they are both classed as 3mm ply. So I need to try and allow for thicker ply, and I'm going to be working to a tolerance of about 3.1, 3.2 within my design work, just so I know that all of these pieces can fit together. Now don't be put off by the fact I'm using Illustrator. You can do this in something like Inkscape, which is a free open source version of Illustrator. You can also do this directly in Lightburn. It is just simple basic drawing at the end of the day. So the first thing I did was drew the outline of the gun shape that I was trying to achieve and made sure I was happy with it. The next thing I did was drew the mechanism that I wanted to operate inside. Now I did this to try and get an idea obviously of how this is going to work, how it fits in relation to the actual positioning within the gun. And if I quick click on this and just show you a rotation, hopefully it will start to give you an idea of how the mechanism works as the trigger is pulled and releases that cog at the back. Now whilst this is a fairly simple mechanism, it obviously does take an element of your imagination to try and envisage this working within your head. But once I'd done this and I was happy, it was then trying to figure out all the different parts needed to create the gun itself. First I started with the mechanism. Obviously we've got the cog that releases the elastics, we've got the trigger itself, and then we've got a few additional pieces. Now these usually pivot on something like a piece of dowel, but the whole point of this project was I wanted to do it completely from laser cut parts. So these little pieces assemble along with these circle pieces, and it essentially creates its own type of dowel that all of these parts can pivot on. So I just briefly spoke about the tolerances within your material, and it is parts like these two here which are key to getting that correct. These slot together and therefore the slots need to be accurately sized to the material. If they are too big, the parts will be loose. If they are too tight, they will not slide together. So this is where your tolerances come into play, and you want to allow just enough room for it to be a snug fit, but not too much room that there is a lot of play between them. Now we also need the outside of the gun obviously to encase all the moving parts and make it look nicer, but we need middle sections with the part taken out here to allow the mechanism and the trigger to actually operate when the trigger is being pulled. So once I was happy that I'd achieved all the parts that were needed, I then drew out a bigger board. This is 400 by 400, which is the piece of material that I'll be cutting everything out of, and then lay the parts out in a nested format to try and make the most of the area that I had. Now obviously I've got double of everything. This is to give the gun more strength, but then down here I've also got extra little parts just in case something happens to them. If you have blank space on a design like this, you may as well fill them up with spare parts, because otherwise it is essentially essentially just dead area. In the downloadable files for this video, I'll try and lay this out as best as I can on smaller areas as well, such as 830/80 and 300 by 180. So no matter what size machine you have, hopefully you can cut this out. So the most complex shape on that layout is probably the cog that releases the elastic bands. And I'll quickly show you how to draw that out. So we're going to come up and use the circle tool, and we're going to draw an elongated ellipse. So we're going to pull this right the way down. We then want to add a little bit on the top, that is the part that catches the elastic band. So we're going to zoom in, and we're going to draw another ellipse somewhere in this area. We're then going to line these up roughly. It doesn't need to be perfect at the end of the day. We're going to put it like that. Select both shapes together, and then we're going to merge them into one using the tool over here on the left hand side. That now makes one shape. Obviously we've got the lip to catch the elastic band, and then obviously the rest of the spoke itself. But we want to get rid of the bottom half of this. So we're going to come up and grab the square, and we're going to draw over the bottom part of this, maybe to about there. And select both shapes again, and we're going to use the punch tool to get rid of one of them. So there we're just left with the top section of the spoke that we're after, but we now need to repeat this round in a circle. So we're going to come over and use the circular array tool, and we're going to select this to 12 copies as we can see here. Obviously if you want to put more on, you can. And we look at this, but it all looks a little bit complex at the moment. It's because it's all rotating from the center here. So the bottom part is overlapping with the top part, and as I say, it all looks a little bit messy. So we're going to adjust the offset here and bring this down to start and space them out even more. And now you can start to see how we got that shape. So we'll click OK. But again, there's lots of repetitive shapes going on in the middle that we want to get rid of. So we'll use the arrow tool again, select everything, and then we're going to merge this all into one shape. And there is the final shape that we're after, this spoked cog with the little catches for the elastic band. Fairly simple, even though it looks like a complex shape. With the nesting drawing done, and now in Lightburn we can import that SVG. We're going to go File, Import. I'm going to select the SVG and click Open. Now I'm not 100% sure why this is, but whenever I import an SVG from Illustrator, it never comes out at the correct size. So I put a border around it so I can resize it correctly. Now it's showing us 300 by 300. I know this should be 400 by 400, so we will update it. And it has resized it now to the work area that I need. I will delete that border that I added all around the outside. Then in the cut and layers panel, we're going to have the speed and the power set, and I'm doing 2 passes on this. Obviously these settings should be relevant to your laser, not what I am doing. So if you are using a lower powered laser, you will obviously either need to do more passes or at a slower speed. But I'm happy with those settings for my laser, so I'm going to click OK. And the only thing left to do is send this job over to the machine and get it to start cutting out. Now as an extra tip, what you can also do is just print off some of the smaller parts before getting into the larger piece of work. And then once you've done these little parts, you can see how they all fit together. If they all fit together nice and snug, then obviously you can continue to cut out the rest. If they are a bit tight or a bit loose, you can adjust your drawing accordingly to account for the differences. Now I'll show you how to assemble this very shortly, but given this is essentially a prototype, the chance of me getting all the mechanism working correct the first time round was extremely slim, and that is what has come to be. I did a dry run just to test how this worked, and what we can see is that the trigger is working as expected. There is a little elastic band inside there, just applying enough pressure to return the trigger to its natural state. However, when we put some pressure onto the cogs here that the bands will attach to, it lifts up, but then as it comes back down, it is catching. So what we're going to do is just shave a little bit off the edge of this, and that should hopefully allow it then to drop back in place and keep the cogs rotating to release the band each time the trigger is pulled. So to make this easier, I've opened up the side, and it is still a dry fit, everything's clamped in place. But after shaving a little bit off this top bit, what I can see is the relationship between the top and the bottom catch are a little bit too close, and that's essentially what is affecting the mechanism not working correctly. So I've redesigned this, lowered it down just a little bit, and it should give it a bit more space for the cog to rotate every time the trigger is pulled. So we'll get 2 new pieces cut for this and get them in place. So for the purpose of the video, I've placed the new trigger mechanism over the top of the old one. And we can see there is not a huge amount of difference, but it is just enough to allow this to rotate and to catch at the appropriate points when the trigger is being pulled. So with the updated part, time to do another quick dry run. Now this should fire both elastic bands separately, so let's see if it does. Perfect. We'll now get it glued up and assembled correctly. So to help us with assembly today, we are going to be using a bit of CA glue. Now this is Starbond. There is a link in the description area if you want a discount, but it's available from other places as well, and there are other brands to use. We're just going to apply a tiny drop every time we assemble each part, just to help it hold together. We'll move it out the way for now. First thing we're going to do is basically interlock these 2 pieces together, and as I say, we'll just put a tiny bit of glue in between to hold them. Next we're going to add 2 of these to the bottom, so again we'll just apply a tiny bit of CA glue to help hold everything in place, and then we'll drop 2 of these on. The reason I'm putting them down every time I spray the activator is obviously they're small parts and the glue will stick to your fingers. With that set, we'll drop these 2 parts on as well. Again, just put a little bit more glue, and we're going to drop these ones on as well. Next we're going to assemble the trigger in a similar way. Now we do need to put a rubber band through these 2 holes together. I'm not going to lie, it is a little bit fiddly. I think when I release the files, I'll make this hole a little bit bigger for everybody. I'm going to leave them slightly loose for the moment, and I'll apply a dab of CA glue in between them when we're ready to assemble it. But back to the parts that we did earlier. So again, we'll just apply a tiny dab of glue and work through and assemble this in the same way. Now when it comes to sticking the various plates together on top of each other, this is where you want to take time and make sure everything is aligned correctly. Slight mistake there, I applied some glue to an area that shouldn't have needed glue, but you will not be able to see that once it's complete. Now one thing I should have pointed out is when we come to the inner parts, the pieces with cutouts, there are 2 with hooks and 2 without. The ones without go on first, and then we apply the 2 with the hooks later. Now the next part can start to get a little bit fiddly. We've got to drop both of these parts into their relative holes, as well as hooking the elastic bands on the hooks under here. Now there is no real easy way of doing this. This one obviously just drops into place fairly easy. Make sure the little kink parts face away from the back of the gun, because obviously they're there to hold the elastic bands in place. When it comes to this one, the easiest way I found of doing it really is hook the elastic band on from one side, hook the elastic band on from the other side. Make sure it's sitting comfortably within the hook, and then try and drop this into the hole. Obviously there's going to be a bit of pressure on it pulling it back this way. I should also say I've placed in the holding pin here as well to keep it in position, and we can see how this actually works now. So with that in, I'm then going to drop the last piece in and let these sit in place, and hopefully that should stay there whilst we apply the last 2 pieces to finish off the outside of the gun. Now this is where it does become awkward, because you've got to get it in place quickly before the glue sets, as well as keeping everything aligned as best you can. Give that a few seconds to dry, and all being well, everything should still be moving free. Apply the last part. You want to make sure these are pushed all the way in so they sit flush with that last piece that we just fixed. And we'll do a quick test now that's in place. Perfect. Now I'm always one to point out my own flaws. Obviously because of assembling this on camera, some of my layers are slightly out of alignment. What we can actually see is this here is slightly off center, leaning outwards. Now it does mean that in certain places this is a bit stiff, and this is why you need to make sure you keep everything well aligned when assembling it. A few decorative elements on the outside just to finish the piece off, and the gun is ready to go. The rubber bands being used are about 75mm to 80mm in length. In the rubber band world, these are known as size 18 or number 18 elastic bands. The mechanism will easily take 5 elastic bands, maybe more, and whilst it is a toy, remember, just be careful when using it. So the mechanism wasn't perfect first time round, but that's okay. We corrected it and we got there and got it all working. Now, obviously, if you download my files, you can customize them however you want, and I would love to see your variations on the design. So definitely do tag me in your photos or send them through to me on Facebook. Now, please remember, this is not a discussion about guns. It is just about doing CNC and laser projects, and let's focus on what we all have in common. That is everything for today's episode. I really hope you've enjoyed it. Thank you as always, and final thanks goes to my patrons. I'll see you all on the next episode.